Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll discuss the concept of pressure and its types. So pressure, actually we know that the perpendicular force which is applied at a unit area, that is known as pressure. So let me write the pressure here, P equal to the perpendicular force which is applying on an unit area. So F by A, and we can write its unit. We know that the unit of this force is Newton and area is meter square or millimeter square or centimeter square, or sometimes you can write that is also in Pascal. And also pressure is measured with bar. Okay, if you see the pressure gauge, that will be given in bar, or sometimes it will be given kg per centimeter square also. That is different units also will be marked there. Okay, now if you see this relation here, pressure equal to force by area, so it indicates that when pressure force we are increasing, if you increase the force, okay, then pressure is going to increase. Okay, here in that point area will be your constant. Okay, in the fixed area, if you are going to apply some force, okay, and if you are increasing the force, then obviously the pressure is going to increase. But the area is going to increase means force is constant, means your pressure is going to reduce. That means the area is inversely proportional to pressure, and here pressure and force both are directly proportional. Increase the force, pressure will be increased. Okay, so this is the pressure definition and its formula and units. So this pressure, actually it is categorized into four types. First one is absolute pressure, gauge pressure, vacuum pressure, and atmospheric pressure. Now the point is why we will discuss this pressure and why it is required for us. Okay, we know that around us, in our surroundings, air is there, and air is having a pressure. Okay, if the pressure of this air increase or decrease, then that will be difficult for us to sustain in that. Okay, so we should know what kind of pressure level is there in our surroundings. And if you travel different places, sea level we are having different pressure. If you go to mountains, okay, Himalayas, they are having different pressure levels. Okay, so it is difficult for the mountain riders, for them when they are climbing the mountains, they used to carry with oxygen with them. Okay, anyway, that is one part of this pressure. So different places will have some different pressure regions. So here we'll see about this different kind of pressures. Even if you go for industry, in the industry also, basically the power plant industry, hydropower power plant industry, or any power plant industry will be there. When the liquid will be flows through a pipe, okay, when the liquid or fluid will be flows through a pipe, we can see there a big pressure gauge will be mounted there, and that will be gives the value of pressure which is flowing inside this pipe. Okay, so that the technician or the operator can identify, okay, what is the pressure level at this pipe. If any kind of problem will be there, they can immediately take action on that. Okay, so that's why the pressure measurement is very much important in all these areas. Okay, and absolute pressure. First one is the absolute pressure. Let's discuss this pressure. If I draw in a graph, okay, let this is the y-axis and this is the x-axis is there, and while I plot this pressure with respect to this x-axis, okay, now this is the increase in pressure value is there. As I told you that our P atmospheric, that means the atmosphere, in our atmosphere the pressure value is 1.013 bar. Okay, so this is the atmospheric pressure value which is surrounded to us. Now if you take the value of this atmospheric pressure value here, okay, somewhere at this point, and that value is 1.013 bar. So obviously there is some pressure which is below this 1 bar, so some different pressure will be there at this region. Okay, and this pressure will be started from this point, this origin point, okay, this baseline, Okay, this baseline actually nothing but absolute zero pressure. Okay, this is nothing but the absolute zero pressure. This means at this point the pressure value is 0 bar. Okay, that's why it is called as a absolute zero pressure. What about the absolute pressure? The pressure which measures above the absolute zero pressure. That means above to this pressure level, above to this line, what are the pressures are there? This is called a absolute pressure. Okay, here I have taken a 2 points, one point A point, another point B is there. Now if I want to measure the pressure at this A point and B point from this absolute zero pressure, that will be give us a absolute pressure value. Okay, now from here to here, if you want to measure, you can measure this value and that value will be give you absolute pressure. Similarly, this B point, if you want to measure from this point, that will be give you the absolute pressure. Okay, now the next point is gauge pressure. The gauge pressure is nothing but it measures the pressure above the atmospheric pressure. So here we have seen absolute zero pressure and this is our atmospheric pressure, P atmospheric pressure. P atmospheric, that is 1.013 bar. Okay, now the pressure which exists above the atmospheric pressure. Suppose same A point if I consider, okay, so the value from this atmospheric level to this A point. Okay, the pressure value from this atmospheric value to this A point, that is called here gauge pressure. And the value which is below than this atmospheric pressure, that is nothing but vacuum pressure, and sometimes we used to call as a negative gauge pressure. Okay, and this value is to consider as a positive gauge pressure, and this one is to consider negative gauge pressure, or we can say that is vacuum pressure. Okay, vacuum pressure is nothing but it measures the pressure below the atmospheric pressure. That means this is the pressure line, atmospheric pressure line, and the pressure which is below than this, that means the same B point, if you want to measure from here to here, that is called absolute pressure. And if you want to measure the same B point from this region, atmospheric pressure region below than this, that is called vacuum pressure. Okay, or we used to call as a negative gauge pressure. Okay, similarly this is called here positive gauge pressure or only gauge pressure also you can say. Last one, the atmospheric pressure, as I already mentioned that the pressure which is existing in our earth surface or the pressure which is exerted by the air to the earth surface. Okay, so that is atmospheric pressure. So these are the types of pressures are there what we have discussed. I hope you understood what is the meaning of pressure and what is the definition of this, what is the unit of this, and what are the types of pressures are there. Let's discuss one problem related to this pressure. So a question I have taken here, and here it is asked that what are the gauge pressure and what is the absolute pressure at a point 3 point below the free surface of a liquid having a density of 1530 kg per meter cube. If the atmospheric pressure is equivalent to 750 mm of Hg and the specific gravity of mercury is 13.6, density of water is 1000 kg per meter cube. So very simple, we need to calculate the gauge pressure and we need to calculate the absolute pressure. Okay, two things we need to be calculated. So what are the data given here? Let's see. So that one, first one we can see the depth of the liquid, this one 3 meter below the free surface of a liquid. So that is nothing but Z1 equal to, we can consider 3 meter, which is below the surface level is there. Okay, this is Z1 suppose, and having a density is given here rho 1 1530 kg per meter cube. Okay, if the atmospheric pressure is equivalent to 750 mm of mercury, so if the atmospheric pressure is given equivalent to this one, that means we can write atmospheric pressure head let 0 Z0 or ZO, we can write 750 mm of Hg. So 750 mm we can write into meter by dividing 1000 of Hg. So that is nothing but 0.75, okay, a meter of Hg. Okay, next is this is the Z naught given, specific gravity of mercury. So specific gravity of mercury given 13.6. So this one we can calculate the density of mercury, that is nothing but 13,600 kg per meter cube. Okay. Similarly, specific gravity not required for the water, that directly the density of water given, that is nothing but 1000 kg per meter cube. Okay. So these are the data are given for us. Now here we need to calculate first the atmospheric pressure. P atmospheric is nothing but, we can write rho GH. Rho GH. Here in the place of H, I can write the Z. Now here the Z is nothing but this rho O and ZO. Okay. Rho is nothing but the density of the mercury. So that is nothing but 13,600 into 9.81 into Z naught. Z naught is nothing but what we got here, 0.75. Okay. So if you calculate this one, we will get 13,600 into 9.81 into 0.75. So 1,62,000. I don't know whether it is correct or not. Let same value came. Okay. Yeah, 1,62,000 Newton per meter square. Okay. So this is the P atmospheric value. So we need to calculate actually P gas and P absolute. So let's see. P atmospheric, we got it now. Now we'll calculate the pressure value. Pressure value at the depth of 3 meter. At the depth of 3 meter, what is the pressure value is there? So for that case, you can write P equal to rho G Z. Rho 1 G Z1. So at that level, what is given? Z1 value given. Okay, 3 meter. And the density value at that point, at this point, this is the 3 meter is there. At this point, what is the density value is given? That is 1350, I think. No, sorry, 1530. So 1530. So you can write 1530 density and G equal to 9.81 and Z1 equal to 3. Okay, this is the value. So similarly, we can just calculate this. 1530 into 9.81 into 3, 45,027 Newton per meter square. So previously what we have seen, P absolute equal to P gas plus P atmospheric. So this is nothing but P gauge only. So what we got here, so that means this 1,62,000 plus this 45,027 something is there, will get near about 1,45,000 something, will get like this. Nothing but this is the absolute pressure of this liquid. Okay. So I hope you understood how to solve the problem in the pressure related. This is 3 to 4 marks questions will be there. Even sometimes it will ask as a 1 or 2 marks question in the competitive exams. So if you know this concept, you can easily solve the problem related to the pressures. I hope you understood. If any doubt is there in this, you can give a comment on the comment box. Thank you all.